everybody, it is I, your pencil-necked geek, Richard Blyle, here with yet another video. Hey, listen, I'm making several of these. I mean, I just finished the third one. This is my fourth of the year, and we're only about a week into the year, and I don't know why, but for some reason, my depression, I'm getting stuff done. I mean, a lot of times I just can't get anything done, and obviously at this point I can. So these are videos I've been wanting to make for a while. The first few were all about soldering, and thanks to one of my viewers, I actually managed to get that one done. Today I'm going to do another video. I want to talk about computers. And you might be thinking to yourself, hey, Blyle, you're not a computer scientist. No, I'm a theoretical chemist. And I've been programming. I mean, my PhD was basically completed by writing programs in Fortran. My first computer was an old Commodore 64. It actually wasn't mine. It belonged to the university where I was going. I was senior in college, which means it would have been about 1984. And I programmed in the built-in language, which was BASIC. Not graphic BASIC, but basic. And I have been programming ever since. My home programming language is Fortran. But in 1971, the very first, I was 8 years old, the very first commercially available computer called the Kenbak 1 was offered. Now back then, keep in mind this was before the internet, this is before you could order things online, because there was no online. What you could do was go to a tech store. Back then, these days, the tech store is more or less Best Buy. Problem with Best Buy is they're starting to get into sort of home products, which is less techy than they used to be. But on top of that, nowadays, you can order things online. But back in 1971, the techie store was Radio Shack. And they actually had, you could actually buy things like resistors and capacitors and individual electronic components so you could build your own tech. They don't do that anymore. In fact, Radio Shack is not even around anymore, I don't think. Where is I going with this? But the other way that you could get techie stuff was from a catalog. And the Kenbak 1 was offered in a tech catalog where you actually had to write a letter, you had to fill out a little form, you had to send them a check. They would mail you your thing, so it all depended on how fast the mail was how long you could get it. And that was it. The Kenbak 1 back then cost $750, which was a good chunk of change, because remember, we're talking 1971. To put that in some perspective with inflation, that means that these computers ran about $5,500 by today's market. So really, the people who could afford it, they were the Bill Gates, basically. Bill Gates and the Apple guy. I can't think of his name right now. Anyway, so you had to have a little bit of money to start, and the computers back then were very, very, very different. Let's look a little bit at computer technology and how it has been changing. This computer, where is it? Yeah, you can kind of see it here. This computer here, which is kind of hard to see because it's dark, I bought that in the 90s. This was maybe 2000. This was around about the year 2000. So we're talking 23, 24 years ago. And it still runs. Look at this. Now, I've had people make fun of me because yes, this is running Windows XP. And yes, this is Real Player. And nowadays you get so many, I mean, it's been upgraded so many times, it's ridiculous. But you know what? This computer still works. And I don't use it. It's too slow to even connect to the internet today. So this computer I only use to run music. And the music sound quality is as good as it's ever been. I can still put new songs on it. I just have to put it on a USB drive and plug it in so I can add it to my rather extensive library, because this library I've been building for literally decades. This is my new work computer. This is a Surface Pro. You can see that I'm actually starting to write a little program here in Python. This is going to be, well, crime is going to be it's a criminal, criminal prediction. It's software to predict where crime will occur, where it's most likely to occur. And it should be, if it works, it's going to be amazing. And of course, technology is everywhere. Here's my Alexa. I have my, see, and it's already listening to me. And it has, here's my cell phone.
Sorry, what did you say?
And I have my big mega computer. Now, my big mega computer is basically for running quantum mechanical calculations. And you can see here, I actually have it set up so I can keep track. This is using 64% of my CPU, and I am running, whoa, did I just accidentally zoom? I didn't mean to zoom on that. But I am running 14 different calculations here. This computer I put together myself. It is not even connected to the internet. It has, when I built it, which was about a year ago, so it's already outdated, this thing had the fastest computer motherboard I could find. It has the most memory that I could put into it. It has flip this around. Had the most memory I could put into it. The biggest CPU has, I think, like 32 CPUs, core, something like that. Anyway, this is a mega computer. Running 4.24 gigahertz. Shoot. This computer, it's only using 10% of the memory. It's 64 gigabytes of memory. 2 hard drives. The graphics is poor. I didn't spend money on a big graphics card, and it doesn't have a special sound card in it because I'm not using it for gaming. This computer is specifically for calculations, and the graphics in the calculations are low end. So I built it that way. But the very first computer, and the thing is, all of these computers have some form of keyboard. This one actually goes to my Surface Pro. This one is plugged into here. The Surface Pro also has software which acts like a keyboard. And of course I have this keyboard for my mega computer, but I also have a Kenbak Pro. And this is the Kenbak Pro here. And I wanted to show this to you. Notice that it has no keyboard. The Kenbak Pro you had to program in, and I really wish this thing would focus for me. The Kenbak Pro you had to program in bit by bit by bit. used to be the people who own these computers, and this is 50% size. They used to be quite a bit larger, so this is called the micro Kenbak. But the design, it looks it's the exact same design. Why is this not focusing? And this doesn't have a focus feature. There it is. Okay. Anyway, the Kenbak Pro, you have registers that you have to put in. So you have 8 bits. Here are your 8 bits right here. You have to type those in one by one. Then it has, for input, you can clear the input. And the display, I'm not even quite sure what the display, but the sets the addresses. So you have to put in one address at a time. You can read or store into the memory, and the run is start or stop. Now you can program this yourself. There are programs you can write, and I'm not going to worry about it. But notice it has no monitor. The output are just these LEDs right here. These are special LEDs that sort of show different statuses. But in order to program this, you had to put it in byte by byte. And to put it in byte by byte means you had to actually put in individual bits. Now, fortunately, this came, I assume that back then it came with these pre-programmed programs. These programs already in memory. So you didn't have to type them all the time. For example, about the only useful thing I can honestly do with this at this point is to make a clock. Now, the clock, you have to enter things in what's called binary code, BCD. Notice that you have numbers up here. 1, 2, 4, 1, 2, 4, and 1, 2. This one, the first 3. So for example, if you wanted to put in 6, you would highlight the 4 and the 2, and that would be 6. If you wanted to put in some larger number, you had to do it one at a time. So you also have 1, 2, 4, 8 bytes down here. So you can put it in that way, and there's a different name for that. It's the I forget what that's called. Or you could put in bit by bit. Notice that the bits run from 0 to 7. So there are 8 bits here. Computer science always starts with 0, not 1. So I want to make a clock out of this. So I'm going to turn it on. It will go through its self-diagnostics, make sure everything is running. And notice I have the light here that is lit. A little hard to see because it's kind of bright. But this light is lit. Now, before I do anything, if I want to use this as a clock, I need to tell this computer what time it is, because it doesn't connect to the internet, so it can't just look up the time like modern phones, and it doesn't have a battery, so it doesn't remember the time from the last time I set it. So, to set the clock, I have to start the set clock procedure, which means I'm going to press stop and 7. Did that work? Oh, sorry, I messed it up. So, stop and bit 7 at the same time, and there it is. Now it's ready for me to tell it what time it is. I need to clear it out because I don't want that there. I need to clear the memory, then make sure everything is set back to 0. Now, as I'm recording this, and don't make fun of me, it is 2 o'clock in the morning. 2 o'clock in the morning, so I put in the hour first. Now this is 02, because this is a 24-hour clock. If it was 24, I would have to put the 2 in here and the 4 here. But no, this is 02, so I press the 2, and I put it in memory by pressing store. Now, it is currently 22. So I'm going to put in, for the minutes, it is 22. 2 is already lit up. So I'm going to press store again. And to say, okay, go. Now, of course, if I wanted, I could have been to put in 23, but I'm not going to be that pedantic about it. So I'm going to just hit start. It does nothing, or at least it appears to. But what it's actually doing is it is keeping track of the time inside. What I want to do is see the time. So I'm going to use the BCD clock. To use the BCD clock, it will flash back and forth between minutes and hours. So to do that, it is stop and bit 3. Bit 3 is here, so boop. And run. Notice that the 2 is lit up. It is still 2 in the morning. But now, notice the flashing light here. That flashing light tells me that this is minutes. So it is 2, the hour is 2, and it is lighting up 2 in this one and 2 in this one. So it is 2:22. Now we're going to let this run for just a minute. We should see it flat change from 20. There it is. Now it is lighting the 2 and the 1, which makes it 2:23. If we wait one more minute, we will see it go to 2:24, which means these two will be clear. It's going to light this one. It's the second column here that I'm reading. It's the one right underneath the LEDs. 2:20, well, 3. 2 plus 1 is 3. So 2:23. Ooh, this is coming up 43. Something's wrong. Oh, I must have put the wrong time in. I must have put in 42 instead of 22. But that's okay. We're not going to worry about it. You're going to see it work. We'll pretend like it's 2:42. Okay. And 2. Let's see if it goes to 4 yet. 4. Kenbak 1. There's no way for me to move this downstairs where I want it without it losing that time. I'm going to move it downstairs. I'm going to plug it in. I'm going to do it again because I want this running downstairs. Or maybe I'll just leave it up here. But if I do, I need to reprogram the time anyway. I've long believed the computer science programs, the computer science majors, should force students to do old stuff. I firmly believe that they should learn how to use Microsoft DOS. Not Windows, or any flavor of Windows, not the Apple form of Windows, the Linux form. I mean Microsoft DOS. DOS stands for I guess I forget what DOS stood for. Disk operating system. Disk operating system. That was it. DOS came out before hard drives. I used to have one of those computers. My very first computer had no hard drive. It had 5.5-inch floppy disks. And I spent a lot of money to get the extra floppy disk drive built in so I could put the operating system in one disk drive and my program in the other. Or the program in one disk drive and the data in the other. But there was no hard drive. And in order to move things around, you had to use DOS. And when you use DOS, you learn about file systems because you're forced to. You have to understand file systems. You had to put in, it was command line code. So you had to put in command lines. You had to put in, there was no graphics. So you had to put in dir, and it would give you a list of the directory. Something like Linux, for example, you put in ls, and it gives you a list of the directory. It's the exact same thing, slightly different command. But all, you know, that's how you learn. That's how I learned about about file systems and how to organize file systems. Today it's drag and drop. The program behind the same thing. Instead of CP for copy, you actually just move it and it just automatically copies it. But it's the same thing. And if you understand DOS, you understand everything that the operating system is doing. This Kenbak, if you want to understand programming, this is how you do it. Get yourself a Kenbak, micro Kenbak. The beauty of it is that you're actually putting in zeros and ones. If you program in a language like me, I'm writing that crime program in Python. My original language, my home language, as I like to call it, is Fortran. Those programming languages convert something that is easy for you and me, something easy for humans to read and understand, into zeros and ones so that the computer can understand it, because the computer doesn't understand Python. The computer does not understand English. It understands zeros and ones. If you want to understand computer science, get yourself a micro Kenbak. Put in the zeros and ones by hand. And it really helps you understand where this comes from. And besides that, it's a lot of fun. Am I ever going to actually read this Kenbak 1? Am I actually going to read the time off of it? No! What's the point? I have all kinds of digital clocks all over the place. Tell you what though, it's fun. All right, that's my spiel. You don't have to do it, but whatever you do, I hope you have fun.